Hi everybody who is watching this video. My name is Olenjolai Single. I would like to welcome you into this fantastic session. I'm a Tanzanian and I'm from United Republic of Tanzania, the beautiful, fantastic and a unique country and peaceful country in Eastern of Africa. So I would like just to greet you wherever you are, and I would like to welcome you into our official YouTube channel that's called the Tanzania Online A-Level Seki School, OLENJOLAIM in square bracket. So Seki, this is the abbreviations of the word secondary, right? So actually this is online advanced level secondary school. So listen carefully. It is Tanzania, so we use the syllabus of United Republic of Tanzania. Online, so it's not a physical school, it is online. It is that we teach students via the internet. A is standing for advanced level, and SEC stands for secondary schools. So in this official YouTube channel that we are solving a critical and a unique and exceptional problem that existing among the advanced students or advanced level students. So I've pursued the advanced level, okay, and then so I know many problems that I've been facing myself and even my colleagues that have been facing similar problems or in different circumstances, and even those problems are still common. So even the students of our present generations and even the future generations, possibly they might encounter them, because you find that just the stuff for the science changing rapidly. It means from the simplest basic physics, for example, to the advanced physics, where you find that there's a lot of complex issues that the students may encounter themselves along the way. So I have experienced many problems, such as just I failed to understand some of the concept. Maybe I spent much time. I was not able to read all the reference materials, because you find that the volumes of one physics book, so it's just like this one. So you find that that's the one physics book, and it may contains only 3 topics: mechanics, heat, and wave for the advanced level. So we know they are facing many problems. Maybe, for example, that you find, first of all, the common problems is to understand what they have to learn within the limited times of 18 months. So little bit challenge. Okay, yes, you can manage, but there's a lot of troubles. So in this channel, we are solving that problem by taking those complex concepts in advanced physics, in advanced chemistry, in advanced mathematics, and also in basic applied mathematics. We break them into the small slices and we simplify them as well as we can, so that the students can take them easily and even just be quickly and think differently on how to use the material in solving real-life problems, rather than spending much time on understanding, because we have already solved that problem for them. But again, in these YouTube channels also, it teaches students how to think differently, because now you are in advanced level. You have to think how you can use the knowledge you've been acquiring from the primary educations to secondary to all-level educations, how you can use that knowledge to solve real-life problems. It happens that according to our educational systems, it's not possible for the A-level students after graduations to be employed in a particular place, or maybe to be trusted to do a particular activity. But that is about the system. You yourself, you can think differently, and even you can start using and employing the contents that I've been learning for years, from the primary to ordinary secondary schools to the A-level, to solve your own real-life problems and even your community real-life, like I did. I will share to you the testimonies that how I've been used the knowledge acquired in those real-level primary, secondary or ordinary secondary schools, and advanced secondary school. So that's the main vision, or the visions of this YouTube channel. So you have 3 departments. You have departments we call advanced chemistry, advanced physics, and advanced mathematics. So today we are in the departments of advanced chemistry. The subject is advanced chemistry, and then the main topic there is called general chemistry. That's the first topic for the Form 5, and then the topic is atomic structure. So this material again is according to the syllabus or curriculums of United Republic of Tanzania. So you say that these materials are dedicated specifically to the pre-Form 5 students, right? Pre-Form 5 students, also Form 5 students, and even and the Form 6 students. So these are the targeted classes, Form 5, Form 5, and Form 6 students. So that's the contents that we are going to teach. And the topic, because the main topic of general chemistry, there's two topics, the atomic structure and the chemical bonding. So we are in atomic structure, and I would like just to do the quick review. I have already taught session 1, session 2, session 3. Today we are going for the session 4, which is titled as hydrogen spectrum, right? And then another thing is, I would like just to share with you a couple of the things before we start the session. Number one, we'll be uploading, you know, advanced chemistry is very intensive. Advanced physics is very intensive. Advanced mathematics is very intensive. At least basic applied mathematics is not even higher in volume, it means in content. So we are going for these 3 subjects, so in these YouTube channels, we are going to upload hundreds of the videos on our YouTube channel. So for you to get official notification from the YouTube community, you have to make sure that you subscribe onto this YouTube channel so that the YouTube community will give you notifications once we apply any new video. Again, remember that we are recording the live class, a very serious class, and in this very serious class, we'll be taking the contents we are teaching by using the high definition multimedia equipment so that we make sure you get everything that just like in the physical normal class, right? So that's the first thing. The second thing, also we insist, our main desire, our strong desire to see that millions of the students in every country get help on these materials that we are offering to them during the year learning process, right? So make sure that you share the contents with your colleagues, with your classmates, with your elder brothers, with your young brothers. So share with them, because you know this is the secret of science and engineering, right? So that's the second thing. The third thing, also in every video, I insist you to read the description below every video, because you'll find the further explanations on concerning about the video, and even also you'll find the further details and even the links for you to access our other official YouTube channel, because we have currently have 6 official YouTube channel, so we still have other 5 that maybe you might not be familiar and you don't have the links, and they are beneficial just to incubate the students from the O level, means from the Form 1 to the undergraduate level, to the bachelor level. That's our intention. So that's the third thing that you have to. And in that descriptions also, in case you want to join me and you feel from your heart that you want to offer God the Thanksgiving offering through this Tanzania online advanced level secondary schools, then you'll find that there is 2 ways that you can send your seed or your Thanksgiving offering or your offering, right, from your heart. Any amounts that will be accepted will be received in order to afford the running cost for these programs, because there's a high running cost. I'm not there, God didn't allow me to mention or present to you, but know that there's a high running cost for this project, and it is a huge project, it takes much time, so there's a need of the running cost, or there's a need of money in order to facilitate it, so it has to reach its end. So there you find also one of the methods. You can do the mobile transactions by using this telephone number. This is Thanksgiving offering, so you can send by 0759745331, and the confirmation name is Olenjolai. If you want to do the bank transaction, in description below, you'll get even the account number and account name. So your seed or your offering will be received and will be directed to the different angles to cover, or it means that it just different angles of running cost of this program. Okay, and then the fourth thing, which I insist you that to make sure that you can average. It means you can weigh these videos, and then you can say either you like or you don't like. Again, another thing which will be the last one, our classes are incomplete without giving students a chance or an opportunity to ask questions. So we'll be teaching. Well, we don't have any students in this class, but we have the students online. Please use the comment section below each video to ask your questions. I'll try my level best to go through and answer, and even some other students that can answer your questions. So make sure that you do that for your own understanding, because our intention, our main objective here, to to let every student to understand and love advanced chemistry, advanced physics, advanced mathematics, and even basic applied mathematics. So we'll be transforming you day after day, lecture after lecture, video after video, session after video, after session, until you return or you restore your original love for science and the mathematics, right? So make sure that also you ask questions and you read questions have been asked by other students, and even yourself you can answer some of the questions. And lastly, this is the warning that I would like just to give at the beginning, is that remember, Olenjolai does not know everything. I don't know everything about advanced chemistry or general chemistry. I just know a little portions of it. But I'm ready to share or to teach what I know. I'm still learning about general chemistry or advanced chemistry because I like it. Okay? So if that's the case, this is the serious program. Take all the required. Make sure that you have your scientific calculator like this one. If you don't have one, you can also go to the description there. I used to sell it online and I can ship it across the country. So make sure that you have your scientific calculator, and also make sure you have your syllabus, right? Your syllabus book, that this is very important according to your country. So remember, this material might be used in America, in Africa, in any continents, okay, in Africa, in Asia, in Europe, you see, and then even North America, South America. So this in Eastern Africa, in Northern Africa, in Central Africa, advanced chemistry is likely. It's likely when we learn about atomic structure. This is the common subject in the world, but we should have at least a focus, because the syllabus or the curriculums is just minimizing some of the issues have a particular focus. So that's why we refer the syllabus of United Republic of Tanzania as a reference, but material might be used elsewhere. Good. So if you are ready right now, let us go to the business. So the first part of this lecture is a quick review of of session or lecture 3. Lecture 1, lecture 2, lecture 3. The main focus of lecture 1 and lecture 2 and lecture 3, for example, in lecture 3, it means that I taught you how you can solve problems, right? Solving or problem solving. So problem solving, okay? Problem solving on what? On how you can compute the average atomic mass, or relative atomic mass of an atom, right? And then simply also I taught you about spectrum, right? So we call it spectrum, right? Mass spectrometer, or we call it mass spectrum. So I talked about spectrum, and then I talked about mass spectrum, right? And this mass spectrum, if you do remember, we say that this is the graphical representation of what? Here we have relative abundance, right? That's what abundance is in percentage, right? And here we used to have what? Atomic mass, right? So here we have what? Atomic mass. So atomic mass. So because you have atomic mass, so here we have spikes representing what? The isotopes of what? Of an atom. Suppose that these are the spikes. So you find that these are the values, and here there's a corresponding value, and here there's a corresponding value. And then if you do remember that we say that relative atomic mass, this is given as what? Summation, right? Of what? Of the product. Summation of the product between what? So you say summation of the product between the relative atomic mass, yes, it means that between the relative abundance, right, times what? The atomic mass of the particular isotopes. So atomic mass of particular of the isotopes. And then so divide by what? Summations of what? Of relative abundance, which if it is in percentage, it is 100, right? So in case that you didn't go through this lecture 3, it is still in this YouTube channel, so you can take them, and I insist you, make sure that you go through these contents several times as you can, so that you may grasp the concept and you may understand, and even you eliminate the troubles that you might come along. So I would like just to give you a short time for you to think through, to remember what I taught you, so when I will be taking on with hydrogen spectrum, you know what is going on. So, well, so I think that now you have achieved it, or you have remembered yourself what has been going on. So let us go to the today's sessions, which is lecture 4 or session 4, which is hydrogen spectrum. Say hydrogen spectrum. This is a very interesting subject in the atomic structure, and we find this concept of hydrogen spectrum in advanced level. So remember during the Form 2, we learned about the atomic structure, but we just discussed about the atomic theory, right? And basically that was atomic theories and its amendments, and just a few things about the isotopes and the, isobars and so forth. Just we covered a little part of general chemistry. But the concept of hydrogen spectrums is new, so you have to make sure that you concentrate, because I want to simplify this concept, and I want to tell you that you will never forget it for the rest of your life, because I will simplify, and even I will insist you to go through and make it to enjoy rather than to hate, right? So in this concept of hydrogen spectrum, before we go into the concept of hydrogen spectrums, let us start with, I would like just to start with definition of terminologies. So in this concept, in order for us to understand, we need to know definitions of these terminologies of hydrogen spectrums, or the most used in hydrogen spectrum, right? So hydrogen spectrum. This terminology, we used to find it when we be learning wave for advanced physics, but it's better also to understand them in perspective of in perspective of chemistry. The first terminology is, we call it, or it's called the electromagnetic spectrum, right? So it's electromagnetic spectrum of light. So say electromagnetic spectrum. Electromagnetic spectrum. Say electromagnetic spectrum, right? Electromagnetic spectrum. Electromagnetic spectrum. So the fundamental question that we find there is define the term, right? Define the term electromagnetic spectrum, right? Pause the video and then remember what you have covered during your Form 4 education. What is electromagnetic spectrum? Right? There are different definitions in different perspectives, but just I found one of them that I want to share to you. Electromagnetic spectrum, electromagnetic spectrum, is the arrangement. So this is the arrangement. This is arrangement of all types. Arrangement of all types of radiation. All types of radiation, right? All types of radiation in order of 40, in order of increasing wavelengths, or in order of decreasing frequency. So this is G, frequency. So this is definitions of what electromagnetic spectrum. We have electromagnetic spectrums of the light. Do you remember it? How many bands are there? We have 7 bands, right? The longer it means that the bands with the longer wavelengths is called radio wave, used in telecommunications or in communication system. The next one is called microwave, also used in telecommunication and communication system. The next one is called infrared or IF. It means IR. It means we call it IR, infrared radiations. Then the next one is what? Ultraviolet light. Then the next, after ultraviolet light, is what? The fifth one, because the ultraviolet light is the fourth one. The fifth one is what? Is it gamma? What the fifth one? Visible spectrum, right? And then after visible spectrums, yes, visible spectrums and ultraviolet UV light. I think that I don't exactly remember, but I think that I have it here, if I'm not mistaken. But this is just in terms of what of color, okay? So unfortunately that I don't have here, but you still remember the arrangement I just mentioned. So you have radio wave, you have microwave in order, and also you have infrared. So the next one is visible, yes, visible spectrum, right? That's the first one. Then the fifth one is what? So the fifth one is what? Ultraviolet light. And the sixth one is what? X-ray. Then the last one is what? Gamma rays. So we say that the electromagnetic spectrum, this is the arrangement of what? Of all types of what? Of radiation, in order of either increasing the wavelengths or in order of what? Decreasing what? The wavelengths. Let me give you example. Electromagnetic spectrum. Example, electromagnetic spectrum, right? Electromagnetic spectrum of what? Of white light or of light. So if you arrange them in order of increasing wavelengths, right? So the first one, I told you that of decreasing wavelengths or decreasing frequency. Okay, radio wave, right? Radio wave. And then the next one we call it microwave. Microwave. Then the next one we call it infrared. So infrared, we just say IR in abbreviation. Then the next one is what? Visible light. Say visible light. The next is what? UV, ultraviolet light. Then you have what? X-ray. Right? Then you have what? Gamma rays. Okay, we have gamma rays. So between the gamma rays, I think that you start gamma rays and then we have X-rays at the last, if I'm not mistaken. But you have to check. And then you have what? X-rays. So these radiations, it means that if we move from radio wave to the X-ray, here we are decreasing what? We say we are increasing frequency. We are increasing what? Frequency. Because this is means that this the X-rays has high frequency more than radio wave. But if we move from X-ray towards the radio wave, here we are increasing what? We are increasing wavelengths. We are not opposing what has been said in the definition. It means that the definition says that this we can arrange all types of radiation, right? All types of radiation. It means that, for example, from X-ray to the radio wave, when we are increasing the wavelengths, or at the same time we are decreasing what? Frequency. So here we are increasing the frequency, but we are decreasing what? We are decreasing the wavelengths, right? Here we are increasing the wavelengths, but we are decreasing what? We are decreasing the frequency if you move from X-ray to the radio wave. We can also define electromagnetic spectrums in terms of increasing frequency or decreasing wavelengths of the spectrum. So that's the first terminology, because we'll be discussing about the hydrogen spectrums is well influenced by the light, right? The amounts of the light are being absorbed by an atom. That's the first terminology. Okay? If you have any questions, please ask me in the comment section. The second terminology, this is common. You met it during your Form 4 also. Okay? When you'll be learning about wave. So we have a term called wavelengths. So the term wavelengths is not new. You learned the topic called the wavelengths during your O-level education. Okay, during your O-level education, you learned the term or the terminology called the wavelengths. But let us remind ourselves, because you're learning in chemistry. There you learned in physics. So you might be surprised that if you find the course of wavelengths in chemistry. So we want to define. So we have wavelengths. So the fundamental question, we are chemists, we want to understand what is wavelengths. So because you know it, you learned it, and possibly wavelengths, right? Wavelengths. Okay, what is wavelengths? So you know, you met it, so you can pause the video and then you can try yourself to write a definition, then you continue to watch the video to make corrections. That's the best way that you can learn through these materials. So what is wavelength? So we say wavelength is the distance between two successful points of the wave. So is a distance. So wavelength is a distance between two successive, say successive. It means that adjacent, successive points. Successful points, between two successful points of the wave. of the wave. Example, the wavelengths, the distance between two successful crests. So example, okay, example, wavelengths is the distance between what? So wavelengths is the distance between what? Two successful wavelengths. No, two successful crests. Two successful crests. But also can have another example. We say the wavelengths. We can say that also wavelengths is the distance between two successful trough. So this is cresting and that is trough. So just to remind you what you've been learning, or to prove what you are thinking in your mind, suppose that this is a wave, and then suppose that this is time. So you have your sinusoidal signal like this. So this is, we call it crest, and this we call it trough. Right? So the half cycle below the time line, we call it what? We call it trough. And then the one there at the top, we call it what? We call it crest. So because we have number of these terminologies, so let me sketch. Just have a sketch of the wave, right, like this. Suppose that this is distance. So this is distance. And then suppose that this is amplitude. And here also we have amplitude. So even on this side that we still have amplitude. So this is dotted line. Like this one, this is time. I'm trying to sketch. This is origin. So you find that it is sinusoidal. So it's a sinusoidal signal. Right? And then here I can prolong to the negative side. So I say that all of this, and even this guy, this we call them in physics or in chemistry, crest. So these are the three crests, 1, 2, 3, right? And then this one, and this one, and this one, and even this one, we call them what? Trough. So we say that the distance between two successful crests, for instance, that the distance between the amplitude, I'll define about the amplitude here. This is point A. Means its distance until the amplitude of the second of the next successful crest. This is point B. So the distance between these 2 points, the distance between the amplitude of the first crest and the distance between the amplitude of the second crest, this is what we define as what? Wavelength. So wavelength is the distance between the amplitude, or it means that the maximum points of the two crests. Similarly, also you can define it that maybe wavelength is just a distance covered by the complete wave. So you can define that this is half cycle and this is the half cycle. So simply, even here you can define as what? Wavelengths. But because of the issue of cancellation, that's why that we don't prefer these demonstrations. We refer more about this demonstration. If you want to discuss it from the perspective of 40 of trough, means we can find the wavelengths as a distance between the maximum displacement like this one. So here we say that the distance between these 2 points, we call it in chemistry or in physics as what? Wavelengths. So I think that I added something valuable in your mind about wavelengths. Possibly I've been cramming only the definition, but you don't know how stuff are well represented. Then the next terminology we call amplitude before we go for the frequency. Amplitude. Say amplitude. So the term amplitude is not new, right? So you just have the fundamental question here. What is amplitude? What is amplitude? So you can pause the video and then try to answer on the piece of paper, then continue the video to see whether you are right or you're not right. Trying is a best way of learning science and learning mathematics. Trying doing it to yourself, trying to explain to yourself, so you are doing the practice before you go for the exam. Right? So with this platform, you can pause the video, it means you can stop the video, and then you try the question, and then do the correction yourself, because possibly the solution or the problem will be solved. So the amplitude, we define that amplitude is the maximum. So amplitude is a maximum. Amplitude is the maximum. So you say amplitude is the maximum. The maximum displacement of the medium particle is the maximum displacement. The maximum displacement of the medium particle. The medium particles from the ear resting in position. Medium particles from the ear resting in position. Mean position. So this is the maximum displacement, right? Maximum displacement of the medium particle from the ear resting mean position. So how do we show the amplitude? The amplitude is just like, for example, this is point C, this is the maximum displacement, this is point D, this is amplitude, this one point E, this is amplitude, A, B, C, D, E. And then similarly here, we have some amplitude. So even this distance we call T amplitude. The maximum displacement of the medium particles, from the rest mean position. So this is the rest mean position. So it's the distance from here to the maximum, right? So the maximum displacement of the medium particles from the resting mean position. So it's the maximum distance from the mean position, and that's the maximum distance reached by by the wave. Sometimes that's how we define. So its symbol is what? So the symbol for the wavelength is that one, and then the symbol for the amplitude is A. So the symbol for the wavelength is lambda, and the symbol for what? So just not this one. Let me remind you, because possibly the symbol of of wavelengths, possibly didn't learn physics during your A level, during your O level studies. The symbol of wavelengths is what? Is lambda. 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 Lambda means that is the symbol, and the SI unit of wavelengths. Okay, so the SI unit of wavelengths is called what? So I think so the SI unit of wavelengths. So I say that the SI unit of wavelengths is what? Wavelengths is meter. Is meter. But in most cases for the light, for the wavelengths of the light, this is expressed in what? Is expressed in either nanometer, which is nm, or it can be expressed in angstrom, right? Angstrom. So this we call it angstrom. And the symbol for the angstrom is this one. You have to be familiar because we're going to use these two units which you are not familiar when you're being the O-level. The questions you learn about are possibly diameter, hectometer, nacometer, meter, decimeter, centimeter, and millimeter. So we are adding these new terms in these units not in the concepts of hydrogen spectrum. So for instance, 1 meter, right? 1 meter, you know that is equal to 100 centimeter. These conversions, you know it. So then I'd like to introduce to you the new conversion. 1 meter is equal to 1 exponent negative 9 nanometer, positive 9 nanometer. So it means that if you have 1 nanometer, this is equal to 1 exponent negative 9 meter. Similarly, if you have 1 meter, this is equal to 1 exponent 10. So 1 exponent 10, what angstrom? This is the symbol for the angstrom. For that case, it means that 1 angstrom is equal to 1 exponent negative 10 meter. So these nanometer and angstroms are the unity used to notate, or it means that used to support the magnitude of the small wavelengths of the signal, or small wavelengths. So the SI unity, so it's a SI unity of what? Of amplitude for this case is what? In most cases, the amplitude is measured in meter. We don't have amplitude in nanometer, neither we don't have the amplitude also in what? In angstrom. All right. If you have any question concerning about wavelengths, concerning about the electromagnetic spectrum, concerning about the concept that I have told you now, the amplitude, please ask in the comment section. Do you enjoy the terminologies of hydrogen spectrum? I believe that you do. Good. We got the first terminology. The first terminology is not a new one if you took physics during your A-level studies, during your O-level studies, your ordinary level secondary studies. So this term is called the frequency. So I want to just present it. It's called the wave number, which might be a new term for you, or just know the definition. Say frequency. What is frequency? Okay, frequency. Yes, you know we learn a lot of cases of frequencies in mechanics, right? Mechanical systems, in light system, right? Telecommunication system also, because you have radio waves there. So the fundamental question is, what is frequency? When somebody asks you what is frequency, while yourself you have been preparing to solve problems about the frequency of the spectrum. So what is frequency? So he said that the frequency say that is the number. So frequency say that is the number of complete cycles. Is the number of complete cycles per second. Is the number of complete cycles per second. That's the definition of what of frequency. We say that frequency is the number of complete oscillations per second. So remember that, not this point. Cycle, this cycle that I've written there is not equal to the cycle. These are the constant distance from the center to the circumference. While in cycles, we don't have a constant distance from the center to the circumference. Let me differentiate for you so that you may note the difference. So this is the cycle, kinds of spherical shape. While the cycle, so the distance from here to here is not equal to the distance from here to this point, from the center to this point of the circumference. While the cycle, it has a common distance from the center, we call it radius. So the distance from here to here is equal to the distance from here to to here, and this we call T radius. That's the difference between the cycle and cycle. So many harmonic systems, right, or many oscillatory systems, oscillation systems, they don't complete a cycle. They do complete a cycle, or we call it oscillations. So in other words, we say that cycle, the word cycle, right? So the word cycle, this is equivalent to oscillations. So in some of the books, we also use the word oscillation, right? So it's the number of complete oscillations in 1 second. How many oscillations does that oscillatory system, for example, complete? Okay, how many oscillations does the light, if the light is a wave, it means that it's vibrating, for example, it's oscillating, then how many number of complete cycles that light, maybe from sodium or from maybe radio wave or from any source, how many number of complete oscillations when it has been moving from one point to another point might be completed in 1 second. So the SI unity of frequency, so you use this lowercase f for notation of frequency, is what? So the SI unity is hertz, named at the hand of Sir Hertz, who has discovered or discussed or did a lot of research on frequency. Or the SI unity, it might be per second. So you have just two forms of SI unity of frequency. So whenever you meet with the word frequency, now you should not be surprised, right? So that is, so we say that 1 hertz is equal to what? Is equal to 1 per second. Again, remember that because you have light wave lights that certainly some of them there, we call them, they are strong electromagnetic radiations. So 1 kilohertz. So 1 kilohertz is equal to 1,000. So 1 kilohertz is equal to 1,000 hertz. Then 1 megahertz. So 1 megahertz is equal to 1 exponent 60 hertz. Then 1 gigahertz. For example, the speed of the computer, modern computers. This is 1 exponent 9. So it complete means that a billion of what? A billion of oscillations or complete cycles in what? In a second. So that's why we call them high-speed computers. So if you have any question, don't hesitate to ask in the comment section, and then I'll try my level best to answer your question as well as I can. The next terminology before we go, before I teach you how to say late, and then to do the computation, it will be the end of this first part of the session. Remember that this session 4, we have session 4A. I'll break into the small slices. Session 04A, 04B, 04C, etc., etc., etc. Okay. So the fifth terminology, say the fifth terminology, is we call it, or it's called the wave number, or number of radiation. So wave number. So the wave number for this case is just like this. That's the wave number. So we have a fundamental question. What is wave number? What is wave number? So wave number, what is wave number, right? So I found that the many definitions that I found one of them, or it's called wave number, or that is the number of wave per unit length. So it's a wave number, we say that is a number of wave per unit length. In 1 unit length, how many number of waves are represented? Per unit 30, per unit is the number of waves per unit length. Now the meaning of 40 wave number. Or, in other words, say that wave number is a reciprocal. Say reciprocal. So So wave number is a reciprocal of what? So wave number is the reciprocal of wavelengths. So if you have the wavelengths for kTt, you get the terms called the wave number. Alright, so either the case now we have mathematical or in mathematical formula of number, mathematical formula of wave number. So say that the wave number, this is a reciprocal of 40 wavelengths. Right? The wave number. So it's a reciprocal 40, reciprocal of the wavelengths. Reciprocal of the wavelengths. So the SI unity of wave number, which is nu, not V. So this is kind of a special V. This one, the SI unity is per meter. Is what per meter. It's 1/meter. Right? Good. So the next concept, after covering about that, I would like to teach you about how do these terminologies of hydrogen spectrums relate. So I want to teach you the relationship between these terminologies. And this part, we call it a relationship between wavelengths, frequency, and speed of radiation. So we say that the next is a topic, we say relationship between we learn 5 terminologies, but not all the 5 terminologies are